Hello, welcome to this video where I'll be walking you through the automatic analysis workflow for Phantech BioMouse phantoms using the Analytics preclinical software. The phantom is highly versatile and can be customized to include or exclude different organ voids such as tumors, brain, heart, lung, liver, spleen, stomach, kidneys, bladder, and their background region. The voids are fillable with imaging agents for PET, SPECT, CT, X-ray, optical, MRI, and MPI modalities. Phantech's fillable biomimetic mouse, the so-called BioMouse, is used to model the distribution of an imaging agent for protocol optimization, training, and theranostic and multimodal calibration applications. You can find more information about the BioMouse phantoms on the website of Phantech. Let me open it for you. So here's the website, and when you go to preclinical nuclear medicine phantoms, we have here the Phantech BioMouse with some features and description. There's also the data sheet about it with technical specifications. You can open it, and then you have here the overview, and you can see here the different phantoms, the different volumes for the different regions. We also have some information about the phantom in the shared flyer of Phantech and Analytics, and you can find the information about the BioMouse in the flyer. It's here. And of course you can find also a video on our Analytics preclinical YouTube page. Therefore go to our YouTube page, then type in BioMouse, and here's a video showing you how to fill the BioMouse, how to scan it in the SPECT, and how to perform the automated analysis. However, in this video I will focus more on the analysis of the phantom using the Analytics preclinical software. So this tutorial will cover how to perform a full analysis of the BioMouse phantom, from loading the image data to automatic localization and analysis with the Analytics preclinical. So let's dive in. Let me open the software first. To start, we load in an example dataset from our tutorial section, which you can find under Tutorials, PET SPECT, Phantech Phantoms, BioMouse Phantom, Load Example Dataset. You can also drag and drop your own image data into the Analytics or use the folder icon in the top, for example here or under File. Now I will rotate a little bit so you can see here the BioMouse Phantom. As underlay, we have a CT scan and Hounsfield units. And I will change the windowing settings a little bit that we can see it better. Now we have here the rings, and now I can even see the screws. And I will enable the transparent rendering, so I go to 3D, enable transparent 3D rendering, and now we can see inside the phantom. Okay, so Phantech's BioMouse Phantom is Hounsfield unit calibrated for bone and soft tissue. However, if your CT scan is not calibrated to Hounsfield units, I highly recommend performing an HU calibration before proceeding. So if you're unsure how to do this, then the Renzo Phantom tutorial video describes a workflow in more detail. You can find the video under PET SPECT, Phantech Phantoms, and then the Renzo Phantom play video. And if you have to perform a Hounsfield unit calibration, feel free to watch the video and follow the instructions. Okay, after calibrating the CT data, the next step is to calibrate the overlay, so the SPECT data, to %ID per ml. And therefore I go to the overlay. Now you see that it switched to SPECT and the unit is kilobecquerel per ml, and now we do a conversion. Therefore I go to modules, nuclear, %ID per ml conversion, and you see that already the correct tracer was selected, so it's technetium 99. You can also change it if your metadata might not be correct or not correctly written inside the software. And then here you can check the total injection dose, and then I just press apply scale factor. And now the vox intensities were scaled, and the unit is %ID per ml. And the message box tells me to change the windowing settings, so I go to the windowing dialog, I press max range, and now, and this way I can adjust the windowing settings and the signals. Okay. And now we go to modules, nuclear, Phantech Phantoms, and then BioMouse Phantom for the automatic segmentation. And now what you only have to do is you have to select your Phantom. So we have the BioMouse 20 gram here, and just press OK. Automatic segmentation was performed of the BioMouse Phantom. And we can go to class statistics syntactic layer, and what you can see here is the mean intensities and the volume for the different regions. You can save this to an Excel sheet for some further calculations. And in some cases, the image quality of the CT might not be sufficient for fully automatic analysis. If this happens, or if you have any questions or encounter any issues with the workflow, feel free to consult the white paper or reach out to our team. Thanks for watching, and I hope this was helpful. Take care and happy analyzing!